So for example 5, we have a spinner where this is yellow. I suppose I could color this, but I'm not going to today. This is blue. This is red. And this is green. So we're going to spin the spinner and we're going to see how many times it lands on blue, yellow, red, or green. We've spun this 20 times, and the results that we got were the following. For red, we got 5 times. For green, it landed on green 9 times. For blue, it landed on blue 3 times. And then for yellow, it landed on yellow 3 times. And so the question that they're asking us, the table shows the results for which color is the experimental probability of stopping on the color the same as the theoretical probability. Okay, so let's talk about that a little bit. This is experimental probability. Now, experimental is what's really going on. Now, if you look at this, and then so we got to figure out what the theoretical is. So one of the things that I kind of glossed over is what's theoretical versus experimental. Well, theoretical is fair chance. In other words, I have 4 choices. If I look, the circle is evenly divided into 4 equal slices, right? If that was a pie, I'd have one big yellow slice of pie, one big blue slice of pie, red, and green. If we did the probability by area, obviously I drew this by hand, but let me tell you the way it looks in the textbook. It's divided into 4 equal parts. So you have 4 total outcomes, and the probability of choosing any one of these should be 1 in 4. In other words, if I spin this 4 times, I should get yellow once, I should get blue once, I should get 4 out of 4, theoretically, right? So experimental probability, so what does that mean? Theoretical is favorable over total outcomes. And then experimental is successes over total outcomes. Or in this case, total trials. So this would be favorable outcomes, what we would like, versus the total possible outcomes. Okay, so I'm going to let you in on a secret. Maybe there's something wrong with this device. Maybe the spinner sticks on the green, right? So this, in other words, these should all be equal in number. Okay? So the first thing that we're going to do is we're going to figure out all the experimental probabilities for all of these. So the experimental probabilities for red, the probability of red, and I'm just going to abbreviate well, I guess I won't. The experimental probability of red is we spun it 20 times, but we got 5 out of 20, which reduces down to 1 out of 4, which is 25%. Now the probability, the experimental probability of green is equal to 9 out of 20, and we can't reduce that one anymore. The probability, experimental probability of blue is equal to 3 out of 20. Again, we can't reduce that down. And then the probability of red is, or I'm not red, yellow. Which is 3 out of 20 as well. Okay? So now we want to compare the theoretical to the experimental. So what are the number of favorable outcomes? So for the probability of red, you have 1 out of 4 outcomes, and if we were to ramp that up to 20, 4 times 5 gives me 20. 1 times 5 gives, so 5 out of 20 times. Probability of green, theoretically, there's 1 out of 4, which should be 5 out of 20. The probability of blue, 1 out of 4, which should be 5 out of 20. And then the probability of yellow, 1 out of 4, which would be 5 out of 20. So if everything was perfect, in other words, there's no issue with the spinner, we should get equal probabilities. That's what fair chance means. Fair chance means that they have an equal probability of getting each event. Okay? Now, experimental is the reality of what actually occurs. Now, if you look at this, we see that the green here, the theoretical was 5 out of 20, but in reality it was 9 out of 20. So the experimental is kind of like what really happens. These don't always match up. Now, if I were to guess, maybe the mechanism, maybe the spinner, maybe there's something causing it to kind of stick on the yellow. In other words, when you are on the green, when you flick it, what it does is, for whatever reason, it slows down right here in the green area. And so then you would, if you wanted to conduct the experiment again, what you would do is look at the device and see what's going on. Okay? Or it could be a magnet or something, who knows?